All right, so if you're receiving this video, you should have completed the gizmo on your own, and this will help you review it. This is from our period 5 class of us reviewing it together. All right, so period 5, we worked on the gizmo, and you could have chosen to work by yourself or work with others in groups. I'm going to hit reset here, and I'm going to make this larger. For this problem or this section of the gizmo, you were supposed to select isotope A, you were supposed to select theoretical, and you were supposed to let it run. So you let it run. That's probably good. Then you were supposed to look at the graph and just kind of eyeball at first what you thought the half-life was. And thinking about it, we started with 128 atoms. So what, you guys, is a half of 128?
64.
64. So you're looking for where you thought 64 was and trying to guess it. So maybe, I don't know, 35 perhaps was your estimate. Then you were supposed to actually measure it. So you turned on this half-life probe. Here it tells us what the time is, and we're looking for that number of 64 atoms. So you pull and drag this little time probe along until you get 64, and you found out the time was how many seconds there?
31.
31. So that is our half-life. So if we look at this information now, at time 0, we had all radioactive atoms. After 1 half-life, or 31 seconds, you would expect half of them, or 64. After 2, half of that, which was 32. Another half-life goes by, so you add 31 here for 93. Half of 32 was 16. So in the time area, we're always adding the half-life, and for the number of radioactive atoms, we're dividing by 2. Then, so we completed our table here. Then we took this information and turned it into percents. So at time 0, we had everything was radioactive, 100%. Here we had 50% being radioactive. Now we have half of that, which is 25%. Half of that is 12.5%. Half of that was 6.25%. And half of that was 3.125%. So why do we care? This is kind of setting up the math behind what's going on. This is the science part. So I'm a scientist, I found this thing, and by comparing it to known amounts, I can figure out how much is there. So I determined that there's 12.5% of the original radioactive atoms present, and I know the half-life is 47 years. So I want to know how old the material is. So I go to 12.5%. I know 3 half-lives have gone by. My half-life is 47. So 47 times 3 will give me my answer for this one, which is 141 years. Okay, I'll pause right here for a second to see if anyone has any questions. All right, you guys, I'm not hearing any. Then I want to jump down to this extend your thinking part. Here it says, the slow decay of a radioactive materials can be used to find the age of rocks, fossils, and archaeological artifacts. This is a process called radiometric dating. Scientists measure the proportion, like we did over here for number 5, of the number of radioactive atoms compared to daughter atoms in an object to determine its age. Scientists like to use something called carbon-14 because it is found in wood, ash, bone, and other materials that are commonly found like in artifacts. Here it says you could use the model to decay it. The half-life is about 6,000 years. And then you were supposed to estimate the age of these different materials. So here we found this paper or papyrus has about 63% of its original. So it's about 4,000 years old. Here, some charcoal has about 22% original, so it's about 13,000 years old. Here they found a headdress and it has about 79%, so it's not as old, it's about 2,000 years old. And then they found a skull, a Neanderthal skull, and it had very little left, about 3%. So it's about 30,000 years old. And I wanted to make sure that I mentioned this because this is kind of the application for science of figuring out this half-life. So tomorrow, what we're going to do is look at some kind of like story problems or word problems. In this video, I solved 2 of them for you. So I'd like you to copy down the 2 examples that I work. Then there are 3 for you to work through in your digital notebook. And then there's a few more on a practice assignment number 43. So our to-do list looks like this. For Tuesday, we have a video and the 2 sample problems to copy down. We have 3 practice problems in our notebook. And then we have assignment number 41. I'm going to stop this video if I remember how to do that.